All right, welcome class to Discrete Mathematics. My name is Tristan Sprague-Williams. This is my first video, and in this video I just want to introduce the class and what it is going to be. So, this is Math and Computer Science 2100, Discrete Mathematics. This class could be described as an introduction to the mathematics underlying theoretical computer science. That's not a really complete description of what the class is, because a lot of what we're going to study in this class is relevant to applied computer science, programming, and the like. And also, some of the things we'll be studying in this class are very relevant to mathematics and the underpinnings of mathematics itself and theoretical math. So if you're interested in math, if you're interested in programming, if you're interested in computer hardware, any of those things, if you're also just interested in logic and the philosophy of mathematics, this class is going to be super fun. So here are some of the things we'll be studying in discrete math. We'll be starting off the class talking about logic and proof strategies. This is going to be the basis for a lot of the mathematics we do, and also the basis for understanding how computers work on a pretty basic level. Then we'll be learning about things like sets, which is one of the fundamental objects that computer scientists and mathematicians work with. We'll be talking about functions, and we'll be approaching them from a different perspective than you're used to from like an algebra or a calculus class. We'll be discussing algorithms a little bit, not doing any actual coding, but we will be using a bit of pseudocode and discussing algorithms in general. And then later in the class, we'll be working with graphs and trees. This is not the type of graph that you might be thinking of from like an algebra or calculus class. But graphs and trees are a little bit different. And these are also fundamental, really important fundamental objects that computer scientists and programmers like to use. And then right near the end of the semester, we're going to talk a little bit about theoretical machines, which really gets into some of the theoretical computer science that I mentioned. Okay, now despite the fact that this class has a prerequisite of Calculus 1, there won't actually be any calculus in this class. Very little. We'll be doing a little bit of algebra, but most of the math we do is of a kind that you probably haven't seen before. So as we're doing it, you might not even realize, or you might not even feel like what we're doing is mathematics, but in fact it is. One of my goals here is to give you a broader perspective of what math is and how mathematicians think about mathematics as opposed to like teachers. Okay, so that kind of segues into an important question I want to address here in this video, which is, what do we mean by discrete? What does that mean? Is this secret mathematics? Do we have to speak in code? Is the first rule of discrete math, don't talk about discrete math? No, that's discrete with two E's in a row. We're not talking about that kind of discrete. This is a completely different word. Discrete spelled with an E-T-E at the end. Discrete is the opposite of continuous. The mathematics you've been doing up until now in algebra and calculus classes, that mathematics deals with the real numbers. The real numbers are a continuous space. So like you have this nice continuous number line. You've got integers along this number line, but you also have all these other numbers in between the integers, like fractions and also irrational numbers. They form a continuous space. In discrete mathematics, we're not going to really deal with continuous things. We're going to deal with more individual, separate things. One analogy is the integers. So if the set of real numbers is continuous, the set of integers is not. It's more discrete, like -1, 0, 1, 2, 3, etc. So that's one distinction that kind of helps us understand this notion of continuous versus discrete. Another distinction that's useful to think about here is that of analog versus digital. Analog technology deals a lot with continuously varying parameters and like continuous signals. Like in an analog machine, you might have a dial that you can move to the left and the right, and that dial like changes the perhaps the frequency on a radio or like the voltage on, on some kind of machine. Digital, on the other hand, is all about on or off. Digital is all zeros and ones. So in the digital world, you don't have a continuous variation of values for your parameters. You've got on and off, and that's it. And everything is described using zeros and ones. So that's another way to like think about the difference between continuous and discrete. Here's another one. Coffee versus donuts. Coffee. If you want some coffee, you might ask, how much? Because coffee is a substance which we measure in continuous quantities. So coffee, you fill up a cup with coffee, and you don't have one coffee, you have some coffee. Donuts, on the other hand, you don't ask how much donuts, you ask how many donuts. Because donuts are a discrete quantity. Donuts are measured by the number of donuts. You have one donut or two donuts. You don't ask how much donut are you going to have. You don't measure it by pouring donuts into a measuring cup. At least I don't. So this is another way to understand the difference between continuous and discrete. Lastly, I'll just point out that in calculus, you are fundamentally working with continuous things. In calculus, you're working with continuous change. Derivatives, integrals, all that it takes place in this world of continuous variables. And functions in the world of calculus can be visualized as continuous graphs that are changing, the values that are changing and producing a nice curve. That's continuous. For discrete, in this class, functions are going to be a very different thing. We're going to think of a function less as we're not going to visualize it as a graph like this, but more so as a map from one set into another set. So this is what I mean about discrete math. And this is what the word discrete means. So that's kind of an introduction. I'll give you a heads up. This class is going to feel a bit like a variety show. I'm going to try to organize it in a way which makes as much sense as possible and that flows as nicely as possible. But there's a period of time during the middle of the semester when we're going to jump from topic to topic. And it's not a whole lot of relationship between the topics other than that they all come under this heading of discrete mathematical subjects and things, mathematical topics that are relevant to computer science. So there we go. I think it's time to start our first section. So in the next video, I'm going to begin section 1.1, which introduces some logic.